Hi, I'm Tyler Bisbee with California Baptist University, Online and Professional Studies. This is Kinesiology 332, Lifelong Motor Development, and today we'll be talking about gait development through a PowerPoint. As we move through this PowerPoint, we're going to be looking at the gait development as a lifelong progression that starts in infancy and ends in late adulthood. There are many processes to gait development, including the major changes that take place in each stage, the phases of gait, constraints, whether positive or negative, that can be physical or perceptual, and abnormalities that can hinder gait development. So to start off, we're going to be talking about walking. Walking is defined by a 50% phasing relationship between the legs, as well as a period of double leg support, followed by a period of single support. And this is according to Haywood and Getchell, 2014. As we look at walking, we can see walking and the gait process, and we can talk about the phases of gait. We have 4 phases when the leg is coming in contact with the ground and moving through the step. And then we have a swing phase that we'll be talking about. So we have initial contact, loading response, mid-stance, and terminal stance, as we can see in the diagram here. And then we have our pre-swing, initial swing, mid-swing, and then terminal swing to fulfill the entire gait sequence. Looking at early childhood, we can see that childhood is going to be taking place with infants and toddlers. This usually takes place around 7 months when babies start to exhibit the strength that they need and the ability to move their legs accordingly. And with that, they're able to start moving into the walking dynamic or their gait. So some major changes that are taking place with the infants and toddlers in early childhood would be walking is an important milestone in motor development, since it influences the development of cognitive, social, and other complex motor skills, such as running and jumping. Walking can only follow a normal pattern of development if the following major changes occur. We have legs that must be able to move alternately, enough strength to support himself on a single limb, and he must also be able to balance on one leg while transferring his weight to his other foot. With that said, this is going to start taking place around 7 months and move into about mid-toddlerhood. Characteristics of infant movement, we have each step that tends to be independent of the next. The babies are going to have short steps with little leg and hip extension, flat feet, and there's going to be the toes pointing outward to help with balance. Spreads feet wide apart when planted to improve lateral balance or to improve their base of support. And there's going to be little to no trunk rotation, and the babies tend to hold their arms up into the high guard to help them with their balance. All of these steps are going to lead to better balance for infants and toddlers as they start to learn to walk. And then we have people continually changing the way that they walk, so the constraints are going to change as the infant and toddler grow and become children. Children reach certain milestones in development that prepares them to walk as well. Our constraints physically, we're going to be looking at rate limiters in early walking, and our rate limiters are going to be our muscle strength and balance. Also, there will be environmental constraints. Babies, infants, toddlers, they may be living in a home where the parents are going to be setting up these environmental constraints, whether to help them improve in their walking or to stop them from being able to get to certain places in the home. So these constraints are going to alter their ability to walk, learn to walk, and how they develop when they walk. We're also going to have the ability to maintain balance. It's going to take time for babies to learn to balance their head, balance their body. They're going to start with their sitting positions, their crawling, and then they're going to move into their walking. And then we also have task restraints. These task restraints are also going to be put in place by parents that are going to help their toddler or their infant learn to walk and develop through these gait cycles. And then perceptual, we're looking at task restraints as well for constraints under perceptual. In early childhood, we can see abnormalities in such as Down syndrome, where this is a condition in which a person has an extra chromosome, usually the trisomy 21 chromosome. And what's going to happen in 95% of the people that have this extra chromosome, we're going to see that each cell in the body has 3 separate copies of the chromosome 21, and instead of the usual 2 copies that most normal people are born with. So abnormalities are going to be done, and they're going to happen through genetics, usually passed down from mom and dad. This can cause delays in motor milestones, and we can see that while typically developing toddlers start walking between the ages of 9 and 15 months, toddlers diagnosed with Down syndrome initiate gait on average a year later and exhibit atypical gait patterns thereafter. Some of the issues that we run into a term called hypotonia, which is a medical term for a decreased muscle tone. And this can be a lifelong condition, but in most cases, these muscle tones will improve over time. All right, childhood. Haywood and Getchell assert that children usually achieve developmental changes in walking by an early age. By age 4, most children have the essential ingredients to be advanced walkers. So major changes from the toddler to childhood and the infancy to toddler to childhood. We're going to see increase in stride length, fuller range of motion, increase in velocity of walk, and improved rhythm and coordination. Usually in early childhood compared to toddler and infancy, we're going to see some confidence building within their walking and inside their gait cycle. And with that, you'll notice that the children are going to start narrowing their base of support. They're going to surrender some of their balance to become more mobile, to move quicker, start running, getting into the jumping and the playing. And then we have Mueller that proposes that as children age, their gait develops according to a pattern based on their age and height. The results of gait speed variability confirm a successively higher consistency of gait pattern in children with increasing age and body height. So constraints physically during childhood, most children follow a normal development pattern for visual, kinesthetic, and auditory process. Sometimes if there's a physical damage to an eye, an ear, or a limb, the developmental patterns will be impaired. We also have disease and injury that can also impair physical gait development. And then perceptual, there can also be perceptual changes during development, not necessarily have a physical cause. This can include constraints in depth perception, body awareness, or location, difference between similar sounds, patterns, and auditory figures and ground. That's according to Haywood and Getchell. As we think about perceptual as well, we can think of home again. We can think of children playing at home during the day with plenty of light. They're able to move around the house freely, avoid obstacles, but then maybe in the middle of the night when they wake up because they need to use the restroom, or maybe they need to find mom and dad, they want to get up and go play. They might find that they'll have constraints that are going to hinder their ability to move because it's now dark in the room. Maybe the lights are off, they don't have a night light, or maybe there is a night light but it's casting shadows that are creating more obstacles for the child as they're developing in their movement. In childhood, we can see abnormalities such as cerebral palsy. We can also find that a lot of kids these days are coming down with cases of cancer, and there are treatments for cancer that are going to impair gait development. A study by Gilchrist and Tanner determined that chemotherapy treatments for children with cancer can lead to peripheral neuropathy, which can hinder gait development and cause functional changes in walking capacity. Through cerebral palsy, this is one abnormality that can impair gait development in children, and it's a disease or injury such as pediatric cancer or cerebral palsy. According to the Center for Disease Control, cerebral palsy is a group of disorders that affect the person's ability to move and maintain balance and posture. So these abnormalities are going to make it hard for children to develop appropriately with their gait. And as we move into early and late adulthood, I've included some pictures of myself and my crew when I worked in the emergency room. And we had a full range of staff from very young to very old, and that includes our nursing staff and our doctors. So as we look at major changes from the toddlers to the children and now to adulthood and late adulthood, there are not very many developmental changes that occur between early childhood and early adulthood. There are individual changes that occur due to lifestyle and other factors pertaining to specific individuals. Some of these factors are weight gain or loss, changes in strength or balance, injury or gait training. In our early adulthood, a lot of cases come down with trauma. We can see trauma causing issues, whether it's a back injury that may cause para or quadriplegia, or maybe just a broken bone, broken extremity in the tibia or the fibula. And these things are going to alter the way that we are able to use gait as adults. And then as we move into older adulthood, gait may be affected by the body's natural aging process, contributing to gait changes. Constraints, those constraints can still manage that trauma, the legs being injured, maybe a back injury causing us not being able to walk appropriately. We can see that as individuals start to age, just increasing steps in a staircase or maybe a pathway up to the house that has a slight incline. These constraints can put a burden on being able to walk appropriately. So physical constraints in early adulthood are mostly due to injury or lifestyle, such as weight loss or weight gain, and obesity or morbid obesity. And in these adults, older adults, developments such as the loss of bone and muscle mass for aging could provide a physical constraint. Perceptual constraints are more likely to impact older adults rather than the earlier adults. And according to Haywood and Getchell, perception at threshold will most likely show decrements in older adulthood. So perceptual constraints in older adults can also cause physical implications such as loss of balance leading to slower walking speeds. These perceptual constraints, we may find that as older adults who are afraid to fall because they're afraid they're going to injure themselves so severely that they might have to go on hospice or live in a home, a nursing home, or need help, and they're afraid of having to burden their family with that. Abnormalities, we can see one of these abnormalities being maybe a cerebrovascular accident, also known as a stroke. And we have two kinds of strokes. We have hemorrhagic strokes and we have ischemic strokes. Ischemic strokes are very common in older adults, and we can still see it in early adulthood. And this is when a blood vessel in the brain starts to maybe have a clot in it or plaque buildup, and that plaque buildup is going to cause a lack of oxygen from blood getting to the brain, going to cause muscle to start to die with that lack of oxygen, and when there's muscle death, we have a stroke. The same can be said with the hemorrhagic strokes. The issue with this is instead of the muscle dying because of a blood clot or ischemia based off of a plaque buildup in one of the arteries, we can see this as a brain aneurysm that bursts or a weakened blood vessel leak, which is going to leak blood into our brain. It's going to put pressure onto our brain, and as we put pressure onto the brain, it's going to cause the brain to not be able to receive oxygen and blood accordingly, and it's going to cause damage to the brain, and with that we're going to see stroke. And these strokes are definitely going to cause abnormalities depending on what part of the brain is being affected. That's going to cause a patient to lose, or a person, older adult to lose their ability to walk or have proper gait development. As we finish up, we have theories and principles. Haywood and Getchell discuss three theoretical perspectives through which to examine the gait development process. We have the maturational perspective, the informational process perspective, and the ecological perspective. As we move through, though, there's so many different perspectives and theories that go along with gait development and walking and moving into running and those kind of things. So we can move through the theories and principles, and in conclusion, there are many parts of the gait process, including major changes in development from infants and toddlers to childhood to adulthood to late adulthood. There's constraints that are going to affect every age range, and then there's also abnormalities and developmental delays that are going to cause issues with gait and walking as we develop, whether it's happening from genetics or it's happening in late adulthood from trauma or some kind of disease or disorder. And as we finish up, we have our reference page, and I hope that I was able to teach you guys something. Thank you so very much, and have a great day.